Welcome to our lecture on the double angle identities, where we're going to look at how these double angle identities are used to solve trigonometric equations. To begin with, we have an example here which is saying solve the equation cos 2 theta equals sine theta for values of theta from 0 degrees to 360 degrees. Now, when solving such an equation involving a double angle identity, you have to first of all consider all the possible ways in which the double angle form can be written. In this case, the double angle identities for cos 2 theta are given as cos squared theta minus sine squared theta, and the other one is 2 cos squared theta minus 1, and the other one is 1 minus 2 sine squared theta. When you are working out your solutions, you need not to write all of these double angle identities, but you have to choose them from your head, and you have to select the double angle form which is in line with the trigonometric form written in its simplest form, which in this case is sine theta. So from the double angle identities for cos 2 theta, the only possible solution to choose here is 1 minus 2 sine squared theta, so that after it has been written in place of after it has been written in place of cos 2 theta, our equation becomes 1 minus 2 sine squared theta equals sine theta, which is now explicitly in terms of sine theta. And when solving this quadratic equation, we take all the terms to the left hand side and have a 0 on the right hand side, so that our equation becomes minus 2 sine squared theta minus sine theta plus 1. So on removing the negative sign from the squared term, we multiply by minus 1 throughout the equation, so that the equation becomes 2 sine squared theta plus sine theta minus 1 equals 0. So to solve this quadratic equation, we consider the product of the first and last two terms, which in this case is minus 2. Now the factors of minus 2, which will give us a sum equivalent to the coefficient of the middle term, which in this case is 1, are 2 and minus 1, which can be written as 2 sine theta minus sine theta. So 2 sine theta minus sine theta can be written in place of sine theta to have our equation as 2 sine squared theta plus 2 sine theta minus sine theta minus 1 equals 0, which can now be factorized by grouping. So the common factor for the first two terms is 2 sine theta, which will be written as 2 sine theta into sine theta plus 1 minus 1 into sine theta plus 1 equals 0. And our first bracket in factorized form is sine theta plus 1 into 2 sine theta minus 1 equals 0, which means that sine theta plus 1 equals 0, or 2 sine theta minus 1 is equal to 0, which also lead us to sine theta being equal to minus 1, or sine theta is equal to half. Now the PV, which is our principal value for the first equation, is the arcsine of minus 1, which in this case is 90 degrees, and the PV for the second equation is the arcsine of half, which in this case is 30. Now the general solutions to these equations are as follows. For the first equation, the general solution is theta equals 180 n degrees plus minus 1 to the power n multiplied by minus 90 degrees, or theta equals 180 n degrees plus minus 1 to the power n multiplied by 30 degrees. Now, considering the first general solution and letting n equals to 0, we have our theta being equal to 180 degrees times 0 plus minus 1 to the power 0 times minus 90 degrees. What is happened here is this. We have replaced the n in the general solution by 0 and the n is which is the power of minus 1 by 0. So that on simplifying, this first term becomes a 0 and minus 1 to the power 0 is 1, which when multiplied by minus 90 will give us an answer of minus 90 degrees. Then next, on letting n equals to 1, we have our theta being equal to 180 times 1 plus minus 1 to the power 1 times minus 90, which will give us 90 degrees. And when letting n equals to 2, we have our theta as being equal to 270 degrees. Now, considering the second general solution, letting n equals 0, we have our theta being equal to 30 degrees, and letting n is equal to 1, we have our theta being equal to 150 degrees, and letting n equals to 2, we have our theta being equal to 390 degrees. Now, taking the values of theta which are in the range from 0 degrees to 360 degrees, we have our solutions as theta equals 30 degrees, 90 degrees, 150 degrees, and 270 degrees. That is all for today. Thank you for watching.